Welcome to Unit 6, Section 2 of Geometry. Today we're going to talk about parallelograms because we're quadrilaterals and we're parallelograms, and that's the way we roll. It's funny because, they don't roll. They're squares and stuff like that. Anyway.
I'm a disgrace to the regiment.
Yeah, you are. All right, definition of a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So in this case, AB is parallel to CD and BC is parallel to AD. And that's what these markings mean. When we have these little arrowheads, those two are parallel, and then these two are parallel.
Why are you hanging around with these guys? They'll never amount to anything.
All right. So if I tell you a quadrilateral is a parallelogram, one of the ideas you want to get out of that is these opposite sides also, in addition to being parallel, are congruent. So given JKLM is a parallelogram, your thought process should be then that segment JK is congruent to segment LM and segment JM is congruent to segment KL.
I got you now, you rabbit. I'm gonna blow you into a million rabbit cutlets.
Somebody's got it out for a rabbit. So, if I tell you that a quadrilateral is a parallelogram, then you would automatically start to think, okay, not only are the opposite sides parallel and congruent, but these opposite angles are also congruent. So, in this case, if JKLM is a parallelogram, then your thought process is angle J is congruent to angle L, and angle K is congruent to angle M.
Be very, very quiet. I'm hunting rabbits.
All right. All right, so one of the things we're going to look at here is that these angles are going to be congruent, like we have these two would be congruent here, and we'd have congruence here, okay? But we would also state that these two angles here, or these two angles here, add up to 180. So they're supplemental. So if I tell you you have a parallelogram, then the consecutive angles add up to 180 or are supplementary.
Kill the rabbit, kill the rabbit, kill the rabbit. Kill the rabbit?
No, that's not nice. Okay, so given if I tell you it's a parallelogram, and if one of the angles is a right angle, well, since opposite angles are congruent, then this angle L would have to be a right angle. And since angle J plus angle M add up to 180, as angle J and angle K would have to add up to 180, well, 180 minus 90 is 90. So the remaining two angles would also be 90 degrees. So if I have one right angle, then I have four right angles.
I'll kill the rabbit. Arise, storm. North winds blow, south winds blow, typhoons, hurricanes, earthquakes. Smog!
that was dramatic, huh? Okay, so if I tell you ABCD is a parallelogram, well, right off the bat, they're saying right here that these diagonals would bisect each other. So that means those segments are congruent. The other idea we can get from this is that point P, right, this point here is the midpoint of segment BD and segment AC. Okay, so that's another idea you can get out of that. All right, so the diagonals bisect each other.
What have I done? I've killed a rabbit. Poor little bunny. Poor little rabbit.
Well, what did you expect in an opera? A happy ending?
How dramatic. So, if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So we can see that because opposite sides are congruent. So we would have this situation here, and because this third side here is congruent to itself, those two triangles are congruent by side, 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 right? If you remember that from prior learning. So if ABCD is a parallelogram, then triangle ABD is congruent to triangle CDB. Okay, so we have a parallelogram, QRST here. We want to find the value of each variable. So in looking at the X value here, I'm going to use this concept. So here's 5X here, and there's 27 there. So I know that those two sides are congruent. So 5X is equal to 27. So we're just going to do some simple algebra. We'll divide each side by 5. So X is equal to 27 fifths, which is equal to 5 and 2 fifths. Or if we use our calculator, we would come up with 5.4. Now the Y values, because we know the diagonals of a parallelogram bisect each other, right? We learned that earlier. So we would know that this segment is congruent to this segment. So we could then say that those two equations are equal. So we'd end up with setting our equation as 2y minus 5 equals y plus 4. So we're going to subtract y from each side and end up with y minus 5 equals 4. And then I'm going to add 5 to each side. And that takes me over here to find out that y is equal to 9. Okay. Our final piece of this puzzle, we know that if it's a parallelogram, that opposite sides are parallel. And right here we have a segment that is this segment here, okay, which that's not very well highlighted for you. Let's go this way with it. There we go. All right, so that segment is a transversal, right? So we know that since two parallel lines cut by a transversal, alternate interior angles, these are alternate interior angles, those are congruent. Okay, we could have also gone by triangle congruence, that those are corresponding parts. Okay, so I would set this up as 3z equals 33, so we're going to divide each side by 3. And z is equal to 11. Okay, so here again we have x and y. Okay, so let's take a look at this. We know that this angle here and this angle here are consecutive, and we learned today that the consecutive angles are supplementary. So that means that 4x plus 2x minus 6 is equal to 180. So we're going to clear the parentheses, right? 4x plus 2x minus 6 equals 180. So that's going to be 6x is equal to, oops, excuse me, not equal to, 6x minus 6 is equal to 180. Add 6 to each side, and I get 6x equals 186, which I will now divide each side by 6, and x is going to be equal to 31. I also know that opposite sides are congruent, so we're going to set this up as 5y is equal to y plus 8. So I'm going to subtract y from each side, and I end up with 4y is equal to 8. So I'll just divide each side by 4 here, and we end up with y is equal to 2. And I forgot that this side is covered with writing, and we have a drawing coming up, so we'll go ahead and erase that. Okay, now we're going to solve for z. Well, we're going to use the same idea that we learned earlier, that the diagonals bisect each other, so these two things are equal. So I've got 3z minus 4 equals z plus 5. So I'm going to subtract z from each side, and I've got 2z minus 4 equals 5. I'm going to add a 4 to each side, and I get 2z is equal to 9, and if I divide each side by 2, I end up with z is equal to 9 halves, or 4.5, or 4.5.
In the wet barn on the farm down in Indiana, for the sycamore trees where the wabash breezes play.
What small red pine and for a yellow moon that shines. Whining on a little red barn on a farm down in Indiana way. I said Indiana way.